Continuing with problem 1, section 4.2. So we're in part C. This one says find the derivative of this quotient function. So 6x plus 1 over 3x plus 10. So again, if you want to use that memory aid for taking this derivative, we'll have f prime of x. It's low d high, so low function, 3x plus 10. D high, that's the derivative of the top function, that's 6. Minus high d low, so that's 6x plus 1, high function. Derivative of the low function is just 3. And then divide this by the bottom function squared. So there's the quotient rule. Let's go ahead and simplify that. So distribute the 6, we'll get 18x plus 60 minus 18x minus 3. Divide this by 3x plus 10 squared. Combine our like terms. Notice the x terms are going to cancel, so we just get 60 minus 3, 57 over 3x plus 10 squared. Okay, for part D, similar, maybe a little bit more of a complicated derivative. So this is f of t is 4t squared plus 11 over t squared plus 3. Okay, so we take our derivative, I should say f prime of t there, not x. So we can get rid of that, prime of t. Low d high, so low function, t squared plus 3. D high, derivative of the top function, power rule, 8t minus high function times d low, so 4t squared plus 11. D low, 2t divided by t squared plus 3 squared. Okay, so let's simplify that. Distribute the 8t, we're going to get 8t to the third power plus 24t minus 8t to the third power minus 22t. And then we divide this by t squared plus 3 squared. Simplify this and we'll notice that the t cubed terms are going to cancel. Minus 24t, or sorry, plus 24t minus 22, it's 2t. And then t squared plus 3 squared. So there's our simplified answer. And we are going to be able to fit e on here, because what I want to point out on this problem is it looks like you might want to use the quotient rule on it. But as we see, the quotient rule is kind of produces kind of a messy, complicated looking answer. So if you don't have to use the quotient rule, it's really best to not use it. In this case, we can go back to what we learned in the power rule and split this up as two different functions. We're not instructed to actually use the quotient rule here, so we don't have to use it. And like I said, if you don't have to use it, best not to. So we'll split this up as two fractions, just like we did with the power rule, and simplify it. So again, we'll use the exponent properties there. Subtract the exponents, 1 minus 1/2, get x to the 1/2. And then this one we'll just write as 3x to the negative 1/2, bring it up to the numerator, change the sign of the exponent. Now notice that we've got power functions here, so we can just take the derivative now using the power rule. So we'll do that. Hope this is fitting. It looks like it is. Power rule, again, just put the 1/2 in front, multiply it by the 4. We get 2x to the negative 1/2. So just lower the power by 1, multiply the power by the number that's already there. Notice when we put that in front, the two negatives are going to cancel, so we'll get a plus 3 halves x to the, if I lower that by 1, I get negative 3 halves. Sorry if that's cutting off. It's plus 3 halves x to the negative 3 halves there for our derivative. Let's see if I can move that up just a little bit so you can see that. Okay, so there's all of problem 1. That finishes problem 1, so that ends part B of problem 1.